Okay, so let me send you also this link for the calculator that's on the board. Hopefully you've already figured out a calculator that will work for you by this point in Unit 5 because you've had to use your scientific calculator to help you with sine, cosine, and tangent, the trig functions. But if not, there is a handy-dandy link that you can use. All right, so let's get going. What I'd like to do is to really have you guys do this yourself today to see where we're at. I want to see how you guys are doing on these. Okay, so let me put 1 minute on the timer. And then after 1 minute, I'll take a volunteer to show this on the board for us, okay? Okay, so I see a few of you answered quickly, but a lot of you haven't answered at all. Do you guys need more time? You still thinking, or were you still working? Yes, if you have your answer in there, I know you've got it figured out. Amy, Aspen, Cheyenne, Emilio, Emma, do you guys need a little more time? I just want to make sure since it's a test review that you guys are trying it yourself, because that's really the key to, see if you know it or not. Okay, so we have some A's, some B's, and some D's. Nobody chose C, so I guess we'll rule out cosine. And this one is tricky. That's one reason I put it here, because I think the thing that makes this one hard is because there aren't any numbers to work with. You're just kind of thinking theoretically here. So does anybody want to give it a try? Anybody that got the answer of D? Because D is the right answer. Okay, anybody want to give it a try? Everyone's shy today? That's not like you guys. Amelia's going to give it a shot. Okay. Okay, you have whiteboard privilege already, Amelia, so show us how you figured this out. And I'll narrate. So awesome. Amelia highlighted something really important there off the start, that the first thing you want to do is figure out what angle you're going from. That's pretty critical to any trig calculation. You want to look at the angle. So it tells you use angle C. Good. So then, yes, that's right, Anthony. You want to see what side would get labeled hypotenuse, what side would get labeled opposite, what side would get labeled adjacent. So like Anthony typed in the box, the hypotenuse is side. Oh, okay, no, maybe you didn't mean to put that in there, Anthony, but the hypotenuse wouldn't be a C. How do you guys find the hypotenuse? Could you describe that? Yeah, CB is the hypotenuse. So what do you guys look for when you identify the hypotenuse? Because that's usually the easiest thing to identify first. Yes, opposite the right angle. So here's the right angle. This would be your hypotenuse. So that's the thing. We've been doing that for a while now, right? Like even when we used Pythagorean theorem, we had to identify the hypotenuse. So the rules haven't changed. The hypotenuse is still in the same place. So start with that. Opposite means opposite the angle you're using. So that's why I'm emphasizing to you that it's really important to realize you have to understand what angle you're going from. Okay, so good. So looking good so far. Amelia said, well, the two sides up here, so round of applause for Amelia. She even color-coded. I love that. So AB, she said, okay, we need this side. And AC, over here are given. Okay, so they don't actually tell us what they are, but they're saying assume that you know what those are. Okay, so if you look at the labels Amelia put, they're opposite and adjacent. If you write out SOHCAHTOA now, most of the time in this class, I don't worry too much about your spelling as long as I can tell what you're trying to tell me. But here, SOHCAHTOA, if you don't know how to spell this, then it doesn't help you too much. So make sure that you do spell that correctly, because the O and the A, which stands for opposite and adjacent, are over here next to the T. That's how Amelia knew to use tangent. Okay, and then she plugged it in. Now, if you guys chose A, you were really close. You got tangent. The reason, though, that you have to use tan inverse is because, and I know this is hard to type out, if you have tangent of C equals A B over AC, you don't have angle C by itself yet. You have to get rid of the tangent, because the question is wanting just the measure of angle C. And so that's why you have to do the tan inverse of both sides. Okay, so that's why you have to use tan inverse to actually get to the angle itself. Yes, exactly, Devin. That's worded very well. Do you guys understand that now, why it would be D? Give Amelia a round of applause. Very nice explanation. Okay, and like I said, that one's hard because they don't actually give you any numbers to work with. I know some of you have gotten pretty good at figuring this out if there's numbers, but then when they give you one of these where it's more general, it's kind of like, oh, I don't know what it's talking about. So that's why I threw this one up here before you get to the test. Good, Amelia. That's awesome. Not everyone is in that situation. Okay, which is the cosine of 30 degrees? Let's do it like we did last time. I'm going to clear out the answer choices, if it'll let me. I've been having a lot of Illuminate trouble today. Sorry about that. So let me set the timer. I'm going to give you guys 2 minutes on this one, and you might need a little more time, so let me know if you're not quite done. Yes, that's good, Amelia. Perfect. Okay, guys, give this one a shot. All right, guys, let's see what everybody put. If you want to lock in an answer real quick, if you haven't yet, just take your best guess. All right, overwhelmingly B. Very nice, guys. Everyone that answered, you got it correct. 100% correct answers. That's pretty awesome. 5 of you that didn't answer, though. So let's go over this real quick, just to be sure everyone is with me. There are a few different ways to do this problem. Can I have, let's take one volunteer first, besides Amelia, since Amelia already had a turn. I appreciate that, Amelia. All right, Mwada's going to show us her method, and then maybe if somebody else has a different way, let me know, and I'll let you show us what you did up here. All right, sweet. So Mwada is using a special right triangle. She recognized that if one angle is 30, well, one thing to note too, she also knew, even though the problem didn't specifically state it, she knew that it had to be a right triangle, which is an important thing to remember. If you're just using sine, cosine, or tangent, now the law of sines and the law of cosines that we talked about last class, that's an exception, but you're not just, there's a little bit more to those formulas, right, than just cosine of a number or sine of a number. If it's just cosine, sine, or tangent of an angle, then you know it has to be a right triangle. So that's something, first of all, important to realize. And then if there's already a right angle and a 30-degree angle in there, then you can use the triangle sum theorem and figure out that the last angle has to be 60. So Mwada said, okay, I know this has to be one of my special right triangles. And then she remembered the ratios. The side across from 30 is 1s or 1a. You can use any letter, just remember it's 1. 2 square root of 3. Okay. And now she's working on finding the cosine. So remember, in SOHCAHTOA, that cosine's adjacent over hypotenuse. So she's using the adjacent side and the hypotenuse. Okay, very good, very good. Anybody do it a different way? Give Mwada a round of applause. That was perfect. I love that. All right, Devin, show us how you did it. Or you can jump on the mic and explain it, whatever you'd rather do.
Probably explain it just because what I did was I ended up taking a calculator and putting in the cosine of 30, which was, I believe it was 0.8660. And then what I figured was that, well, one of these, if you divided the numerator by the denominator, was going to come out the same way. So I got a little curious and actually went in and took the square root of 3 over 2, and I divided those two, and it came out with the same 0.8660.
Perfect. Thank you, Devin. That is a totally awesome way to do it as well. Okay, yes, see, Nathaniel, awesome. So that's what I said. I'm sure there's probably more than one way you guys went about doing this. If you forgot about special right triangles, you might have actually used Devin's method. So that is totally fine. Oh, great, Anthony. So there's another way to do it. Yeah, they did give you a chart of some really common angles that are helpful to know. And Anthony memorized that chart, and so he knew that right off the bat. So I did see some of you guys answering that really quickly, which is maybe there's more of you that memorized that chart. That's awesome. Give Devin a round of applause for jumping on the mic and explaining that really well. Perfect. Right, Devin, that's great. Yes, absolutely. An excellent way to understand. It always shows that you understand it really well if you can do it multiple ways. So I love that. All right. Square ABCD has a diagonal of 10 meters. What is the cosine of angle DBA in simplest radical form? Okay, so let me throw some time up here on the whiteboard. I'll give you a couple of minutes again, and then I'll take some volunteers. All right, I don't see quite as many answers in. I do see some answers, but maybe this one was little bit more challenging. It is a little bit more challenging, I think, than the others we've gone over so far. And there are a few different ways to do this one as well. What is one method? Anybody confident in their method? Want to jump on the whiteboard? You're like, maybe I'll skip this one. Probably the easiest way, the way I would do it, might be, or the way I would probably initially, the first thing that comes to my mind, that's what I'm trying to say, is special right triangles. Does anybody see that it's a special right triangle? Yeah? You want to show us, Mwada? Yes, Mwada's got it. So even though we have a square, all right, go for it, go for it. If you want to get on the mic, I'll get off. If not, I'll narrate. And the reason this one's hard too is that you're not only combining the special right triangles that we learned in this unit, we're actually going back to properties of squares, which may be a little bit fuzzy in your memory. But remember how this property is easy, right? You guys know that the four angles in a square are 90 degrees. But do you remember the property where if you draw a diagonal in a square that it bisects the angle? So that's how you know that it's okay. Also, if you forgot that property, you could figure it out, because if it's a square, you know these two sides are the same, right? And that makes this triangle right here isosceles. So that means that these both have to be 45. Okay, so you could have figured it out from isosceles triangle. But at any rate, you do need to remember 45, 45, 90, and what you know about the ratio of the sides. So Mwada is using S. We used A when we did it in class. It really doesn't matter what letter you use. Just remember A squared of 2, or S squared of 2. Just remembering the ratios is the key thing. Okay, and then also remembering, so if you're using this angle BDA, I had already labeled this side would be the opposite, this side would be adjacent, and this side would be hypotenuse. And then Mwada correctly said, well, it's going to be S over S squared of 2, because cosine is the adjacent side, which is S, over the hypotenuse. Okay, good. Now, yes, don't forget this last step that Mwada showed, because, yes, oh, I love that vocabulary you used, Amelia. Beautiful. That's exactly what you're doing, rationalizing your denominator. So, yeah, if you forgot to do that, you're looking at these answers like, I don't know. So remember, we can't have, it's not correct math protocol to leave a radical in the denominator, or a square root. That's another word for radical. So you have to multiply both the numerator and the denominator by that radical, and then it moves it up to the top. So yep, very good. D is the correct answer here. Okay. If you were like Amelia and you got to this point, which is awesome, and then you were looking at the answers that didn't match up, don't forget you can do like what Devin said on that last one, where you can take this fraction, change it to a decimal, and take these and change them to a decimal using your calculator and match them up that way. Okay? Man, are you guys able to hear me? It looks like there's really a lot of mic issues. Okay, good. I just see like all the orange and red mics over here. So it kind of looks like mine's maybe behind or going in and out or something. I don't know, but Okay, yeah. I don't know why. I've been having trouble with Blackboard all day. But no one else is seeming to, so it must be something on my end. I don't know what it is, but anyway. Hopefully you guys are staying with me. Okay, let me clear out the timer and give you guys another shot at this one. Go for it. Okay, good. I'm breaking my rule and jumping on the mic before the timer's up. But yes, there's no right angle here, because if you add 55 and 75 and subtract from 180, this is not 90 degrees. So remember what we talked about last time. What do you have to use? Aha, okay, go for it, Mason. I'll let you do it a little early because we're running short on time. Yes, so you could do, well, not angle, side angle, because that would need to be this side, if it was angle, side angle. Yeah, so Mason's got it. You want to use law of sines? The law of sines, and either one of those, yeah, I know, trying to remember. So you can use sine or cosine here, but not in the sense of trigonometry. So law of sine and law of cosines have a little bit more in them besides just sine and cosine. There's some stuff divided and all that kind of thing. So yes, the law of sine said you take the sine of the angle divided by the opposite side, and since we're looking for zy and we have the angle across from it, that's how Mason set it up. So he said the sine of 75, which is this angle, divided by the side across from it, 40, equals the sine of 55 divided by x. He's calling this side over here x because that's what we're looking for. Then from there, cross multiply. Use your algebra. Oh no, it looks like some of the rest of you are having Blackboard trouble. That's right, Mwada. Yes. So you don't have to use the triangle sum theorem. I was just trying to demonstrate that, because I know a lot of you probably thought, oh, I'm going to do the sine, cosine, or tangent, and do the opposite over adjacent, maybe cosine or something like that, or tangent. So I'm just trying to emphasize that this is not a right triangle, so that's why you can't use that. But you're right, Mwada, you don't have to actually figure this out if you already realized that. Yep, so C is looking good. Okay, everybody understand how to set this up? Any questions about this? Is 75 and 55 right there. Any questions about this one? We just went over it last time. And I apologize, I actually forgot to post the recording. I just realized that a little bit before this class. So I'll post Monday's recording and today's recording later. Oh no. Now Blackboard's getting mad at everyone. Yeah, I saw that, Mason. That's not good. Good thing you finished this question first. Okay, here's another one to practice that stuff. So here again, it kind of, now be careful, because angle C looks like a right angle, right? They're trying to see if they can trick you. But what if it's 89 degrees, or what if it's 91 degrees? Then it would still look right to our eye, but trigonometry is not going to work. So yes, good job, Mason. It's going to be a law of cosines problem. Okay. And it tells you up here that you want the measure of angle A. So you want to use the version of the law of cosines that has the angle A in it. And this one isn't too bad until you try to start solving for it. And then, yes, it was, Emma. Yeah, the last answer was 34. Was it, I don't think it's degrees, but wasn't it a side we were looking for? So 34 centimeters. Thank you, Amelia. I was like, I don't remember what the units were. Anybody want to give this one a shot on the board? We only have 6 minutes left, so I guess I won't set the timer on this one. Good. So Mason typed the formula in there for you guys. Now, technically, it's actually lowercase a, b, and c there. The capital A would be for the angle. Oh, really, Emma? Okay, hang on. Let me double check that. Try this one, guys. I'm going to go back and make sure that the last one, maybe, I didn't actually check it myself, so let me double check. Okay, Mason, you want to do you want to work this one out on the board? Is that what you're saying? If so, go for it. Yep, looking good so far, Mason. And Emma, I did go back and check that, and that's incorrect on the test, so I'll go in there and fix that. Thanks for noticing that. But I added points back for your test there. Mason, right here, make sure you keep 4 decimal places. Don't round it to 3 yet, so keep 0.8287 right there. Perfect, perfect. Yeah, it was 0.8287. But it's going to be all right, but I just wanted to clarify in case anyone was confused. It'll still round to 34. You get 34.03 for angle A, but it still rounds to 34. So B looks like the correct answer. Yeah, I was going to say, I don't know. We better move it, huh? 34. Okay, good question. So it was because at this step here, what you would do is you would take negative 265.19 and divide by negative 320, and that would equal cosine A. So you're taking the negative 320 and dividing it out on both sides. Do you guys see that? And it'd actually be, I'll fix it real quick, 8287. Yep, exactly. Then you do cosine inverse. So you get 0.8287 equals cosine A, and then you do cosine inverse of both sides. So over here, cosine inverse and cosine cancel each other out, and you just get angle A. And then if you do cosine inverse of 0.8287 on your calculator, you get 34.03, right? And it says nearest degree, so that tells us go ahead and round it to the nearest whole number. Okay. All right, guys. Well, I have tutor time, so if you do have some questions about this stuff, see me in there. And otherwise, good luck on your Unit 5 test. We have our last Class Connect on Monday for the final review. Bye, guys. Have a good rest of your week.